Hey, everybody, welcome back. It's another episode of Everything is a Spring. I am Jim. Derek, how are you?
Hey, Jim. I'm doing great this week, man. How was your Thanksgiving?
Oh, it was great. I got to go up to Atlanta and spend some time with my parents. Unfortunately, all my sisters are out of town, so it was just me and mom and dad, but it was great. And yeah, it was wonderful. How
That's
about you?
quality. Oh, same. Same old thing. Me and my gramps went over to mom's, had a nice dinner. Did my annual tradition of pulling everything for Christmas out of the attic. So I'm a little sore, but I got my workout in, so I'm doing
That's
good,
good.
man. I have leftovers for days too. That's what I'm really excited about.
Yeah, I do. Is mom sent me home with a whole bunch of food. The turkey that we had this year was just amazing. So mom actually brined the turkey, and then dad kind of does a smoker type thing with our
Ooh.
grill, where he'll put it on the grill, and then he'll have like some cans of wood chips that he kind of lights on fire, and he lets it all smoke in
Oh,
there,
that's
and
nice. Just a little
it's
quick and
really good.
fast poultry
Well,
smoke.
he leaves it pretty slow, so it still
Ooh.
takes probably 3 or 4 hours to cook.
Oh yeah,
Um,
that's about
but
par for
it's
poultry, right?
Yeah, I think so. Well, I think so. Because the problem with poultry, right, is that you don't want to, well, especially with turkey, I think specifically,
Yeah, it's
is you don't
already
want to
kind of
dry it
dry.
out. Exactly. But because of the brining and because that of the way that dad does the turkey, it's just super like
Hmm.
it's not dry at all. It's just
Holes
wonderful.
in
It
all that
falls apart.
moisture.
Yeah. Oh, it was wonderful.
Man, I like Thanksgiving as we're American, if you haven't figured it out at episode 8, right? Like we understand the problematic nature of Thanksgiving, but you got to think about Thanksgiving as it is one of the biggest capitalist holidays because right after it you have Black Friday.
Yeah, I actually really don't like Black Friday. I
Oh yeah?
mean, I think that's just I'm not a very materialistic person, um, and so this idea of like, okay, we've got this day, and there's like the historical context of Thanksgiving, but in the modern context, Thanksgiving really is about, in my opinion, it's about being with your family and being grateful for what you have.
Yeah.
So to immediately follow that up with, hey, let's go buy all of the
Just buy
things.
all of it.
It just seems like it's just such like a whiplash to me.
Yeah, you're right.
Um,
I guess that is like, but here's the thing. My look at it personally, right? Because I'm not, you know me, I'm
right,
not very materialistic either. I'll buy computer parts, I'll buy something nice for myself occasionally, but
right,
it's usually me just using the deals to buy stuff for my family and like close friends, because everything's on
right.
sale. Because I'll be honest with you, I love a good sale. I'm not going to Walmart and fighting folks in the streets to get a TV though. That's ridiculous.
Yeah, it's a little bit absurd. I think it really just, to me, it's just that,
You're
and
right.
I
It is
guess
kind of
maybe
whiplashy to go from like,
yeah,
thankful, buy, consume.
yeah, exactly. And I'm just not a very materialist person, so it just doesn't jive with me. I guess I don't. I mean, I'm not judging anybody who like that's their jam. Like
Yeah.
you do you,
Power
but
to you. I'm buying all my crap online at this point.
yeah, and I think that the online like Black Friday stuff has made it a little bit better. Like,
Yeah.
I don't think you really see a whole lot of people like rushing to Walmart and beating each other up over the TVs anymore.
Dude, it was getting wild a few years back.
Yeah, like I remember when I was a kid growing up, and it's just like we don't want to go out to Black Friday because we're gonna, afraid to get, attacked by somebody for the last cheese wheel or whatever.
Right. And they've gotten better at it, right? I think after they saw all that craziness, the supply and demand, they've figured it out, right? Oh, it's, yeah, technically Black Friday, but we're going to sell you the crap pretty much up until Sunday. So, and
Yeah,
the
yeah,
supply,
it's kind of
there's really not
expanded.
a lack of anything. Like they restock it on Saturday. So
Right.
I think that helps alleviate the I gotta get it now mindset of Americans be crazy, man.
Americans do be crazy.
Speaking
I
as
think
one.
that's true. But I do also think that's just a corporate ploy to sell more crap.
Oh, for sure. Hey, marketing 101, right? Like that is like I thought about this, me and my gramps were talking about it, right? Christmas is no longer the holiday where people buy the most stuff. It's really Thanksgiving and Black Friday because, they
Yeah.
make the demand for it kind of artificially.
Right.
But hey, I got me a Kindle because I love to read and I don't want to incur library charges. So I got me my Kindle so I can connect to the library because consume.
That's fair. Consume media.
But yeah, besides Thanksgiving,
good.
what else you got going on this week?
Oh boy, let's see. So not tomorrow. Well, I guess tomorrow evening. Yeah. So Monday and Tuesday, I will be actually up in Royston, Georgia.
Oh boy.
Yeah. So I'm going to be learning how to operate a CNC milling machine that we are getting for my workplace.
Oh, that's cool
which
as
is
hell.
kind of exciting. Yeah. So that'll be good, and that's going to be interesting because this machine is a little bit older, but it's been updated. With a couple different quality of life improvements, I would say. So I think it's going to be pretty nice. But I just don't have a whole lot of I've got a lot of experience with like CNC routers, but I don't have as much experience with mills. And the real difference between the two is really just the mass of the machine, and then well, how would you call it? The cost for failure, I suppose, right? So with a CNC router, you generally don't have enough power to really hurt a whole lot of like the machine. Whereas with a CNC milling machine, you have a lot more. The drive motors are a lot beefier, and just like everything's a lot stronger. So if you start crashing the machine, you can really start tearing stuff up. Whereas with a router, it's not quite as bad.
That's really interesting. I'm guessing the company's paying for you to go up there, and is it like you're using the machine that's going to get shipped to you, or is it just the same type?
It's the exact same machine.
Oh,
so basically, I'm going to get like a 2-day crash course on like how to operate this machine, how to set up the machine, and then I'm going to be taking a lot of notes. And then we're gonna, I think we're gonna get it moved like pretty quick because they want it in before the end of the year so that they can get like the tax write off.
Oh, smart.
Yeah, so we're gonna have to move pretty quick. But I think we're gonna be bringing it in. Yeah, probably not this week. That'd be a little bit tight turnaround, but maybe. I mean, probably. So I imagine probably next week. So that'd be, I guess, the first week of December. We'd get it set in the shop and then set up, and then hopefully run a few cuts on it before the end of the year.
Right on. And it's good to become the SME for that stuff because when something breaks, you'll know what to do.
Yeah, exactly. I'm actually really excited. I've really wanted to play with the CNC milling machine for a long time.
And it's great when you don't have to do it on your own dime. Like you learn the skill. Yeah.
Exactly. And I think it's going to be fairly straightforward. So I was up there this past Friday, not yesterday, but the week before. And we just went over it a little bit, and I was watching the guy. They turned it on for us. We ran a few programs just to make sure everything looked good, sounded good, worked well. And I was looking at it; it looked pretty straightforward. So I think it's going to be pretty cool.
That's cool.
And I'm excited to co-opt it for my own projects.
Yeah, it's right on brand because this is an engineering podcast.
It is. It is. Oh my goodness. What about you, Derek? You got anything exciting coming up this week?
Nothing much. I've just been enjoying some, a little bit of time away from work, just to de-stress, kind of focus on the family. I've been doing a lot of DIY, just fixings I haven't been able to do, like, throughout the week, right? So, like I told you, I got some devices installed, fixed a couple things around the house. I'm getting, like, I guess, home ownership light, being with my gramps. So,
right.
just being his eyes and making sure things are running well. And I've learned a lot in the last couple years, right? Because I don't have any brothers or sisters. I just got to figure stuff out. But usually if I can learn it once or twice, then I'll remember it. So I'm actually feeling pretty confident with my abilities to just I'm not remodeling a kitchen, you know what I'm saying? But fixing things that are broken, stuff like that.
Yeah, for sure. That's awesome. Yeah, I feel like a lot of people our age really don't tangle with that very much.
Well, I mean, they can't buy a house, so, what's the point?
That's a fair point. Yeah, like we're never going to be able to afford a home anyway, so why bother with the home fix stuff?
Yeah, but you'd be surprised, man. Like, just in my, small amount of adulthood I've been through so far, I've been able to pick up some skills, and especially learning from you, like the woodworking fundamentals has come in handy dividends, right?
Yeah. I think like being capable with your hands, like to be able to even just some rudimentary stuff,
Yeah.
it doesn't have to be anything fancy, but like just being relatively comfortable around like tools,
Hmm.
and being able to put stuff together is extraordinarily useful. I
Oh
mean,
yeah.
just so valuable.
It pays
Um,
itself off in dividends. Like I've probably saved so much money on my car, and it's in much better shape than it would be just because I'm starting to look for those things that before it's
yeah,
just like, oh, just take it to the shop. But it's like, this is simple. Let me do this real quick. And if I need to take it to the shop and they got to charge thousands of dollars, at least I'm getting my money's worth, right? I'm not wasting,
right.
oh, also do this, also do that. But
Yeah, I mean, and like you said, earlier you're talking about you installed like a doorbell, I think.
yeah, something simple, right? Just basic
Yeah,
wiring, You really couldn't hurt yourself if you wanted to with that. But, just having the fact that it's something that might take someone, hour. I busted it out in 20 minutes with a trip to the hardware store to get a washer or two. And
yeah.
I saved myself some cash because it was a secondhand part.
Absolutely. But if you were to try to like get somebody out to do that for you, I mean,
120
it could
bucks.
probably, yeah,
Easy.
$120, $200 easy, because they got to come out to you. So that you got to pay them to come out to you, pay for their
Hmm.
gas, pay for their vehicle, and then also pay for the
The part,
parts
yeah.
and the labor to install it, and then they got to go back home. So like you end up paying for a lot either side of the actual work.
Yeah, I'm a pay of
So
convenience kind of person. Like, if I physically don't have the time to work on something because given my new responsibilities, right,
right,
I'm not going to have my mom waiting for me to install a washer machine. I might pay the extra money for that so that it's done professionally, one less thing on my plate, and I can handle things at the other house. But yeah,
yeah,
I'm content. I needed a break. I need a little vacation. I'm excited for podcast, and I mean,
heck
I'm
yeah,
really
man.
riding the hype from last week because I really enjoyed editing last week's episode. I added a lot more visuals to our YouTube.
I really got to start looking at the YouTube videos, because really I've just been listening to the podcast back to like kind of, I think it's valuable to like kind of get an idea of how we sound and how we
Yeah.
do, to kind of have that feedback of, okay, this is what this is what it felt like in the moment, and now this is what it's turned out like on recording. So I've really been enjoying listening back to it. Plus, it's just always fun to hear your voice, Derek.
Oh, I appreciate that, man. You'd be surprised. Like, I definitely listen to it a lot while I'm editing it, and I've gotten better at like not just listening to it if it comes on. But yeah, I find myself, in the middle of my work week, if YouTube auto plays my video, I'll just let it play, and I'm like, oh, I could do this better next time, or maybe I should have put a picture of that there, or especially with the audio, because I love Spotify. Like, I have podcasts running almost all week, if not music.
Yeah.
So it's weird to see something that you made like on a website, right? Like hosted. It's just like, huh, I did
That's
that.
wild. I did that. Yeah, exactly. It's like seeing. Oh my gosh. Yeah, it's fun. I still haven't seen like a whiskey grail just like out in the wild, like in a store shelf or something like this, other than the ones that we stock.
Yeah.
We've got a couple like local ones, but like when that happens, it's going to be really weird.
Yeah, right.
Really
It's like,
cool.
whoa, wait a minute.
Wait a minute, that's my product.
Yeah, I'm excited. My whiskey roll, I think it comes in today. So hopefully by the time the podcast is over, I can check my mail.
Excellent. Yeah, we actually so. Oh my gosh. So the laser that we use to do all of our customization and like a lot of our some of our pretty critical bits of production actually went down last weekend. So not only was so my last Friday was just this mess of my car broke, and then I get a call and they're like, "Hey, where are you?" And I'm like, "I'm in Alberton, Georgia, and my car is broken." They're like, "Ah, well, the laser's broken and we don't know how to fix it." So I was like, "Oh, oh, goodies." So that was fun. But yeah, we managed to get that up and running. So we've been able to kind of catch up with our production and customization and stuff. So that's been good. But I'm really we've kind of got it like jury rigged together, and we're waiting on basically the motherboard has blown.
Oh.
So we've had to bypass the part of the motherboard that's blown in order to get it to run. And so it's just kind of jury rigged together now and held together by cable ties on the back end. So
I would say if it ain't broke, but it is broke.
We are anxiously awaiting the new part so that we can have some confidence in our machine.
Yeah, I can see that. But hey, I mean, if anyone's going to jerry rig it, it's going to be Jim. So I'm glad that at least production didn't halt. So that's the key.
Yeah. Well, so the great thing about it, so I actually am no longer the, for a while there, I was the shop manager of our local makerspace, which is the company that has this laser. But I've actually stepped away from that position to be more focused on Whiskey Grail. And so the great thing about it is I didn't even have to fix it.
Oh, perfect.
So I did kind of the weekend patch job, and then when Monday rolled around, Jonathan, who basically is my replacement, he comes in and he starts fiddling with it, and it actually had a different issue. So we fixed it the first time, and then it had another problem, which turned out to be the the motherboard, and we think that was really ultimately the root cause of both issues. But anyway, and so he did all the jury rigging after that, and I didn't have to touch it, which was phenomenal.
Right on. Hire good folks. There you go.
Yeah, it has been great. So.
Well, should we?
Well, I think that's enough preload for one day.
I could agree. I think we got some good stuff in there. A little update for what we missed last week.
Yeah. Last week we had a pretty beefy content episode, so we didn't do quite as much preload. But let's go ahead and jump into it. So, Derek, I've got a question for you.
All right, Jim.
What is your favorite type of weather?
My favorite type of weather. Ooh, a nice not overcast, but just partially cloudy, sunny day, a little bit of a breeze. I would say sailing weather. Perfect sailing weather.
Yes, that's wonderful. I also am a big fan of sailing weather. Derek, what do you feel like how do you feel about thunderstorms?
I do enjoy thunderstorms, admittedly. I say that until I'm actively camping under one. But, from the comfort of my house, if I have time, I'll go stand on the porch and just watch the storm roll by if it doesn't get too dangerous. But I love thunderstorms. I used to in thunderstorms, and I learned that I should not do that.
That's like standing underneath the tree in the thunderstorm.
It's right after college, pandemic times. I was like, I'm not moving. I got a tarp up. I'm staying right here.
I'm right here. One of my favorite sounds is actually the rain and thunderstorm, falling onto a tent.
Ooh,
right?
Yeah.
Like the canvas tents at Woodruff, the rain coming down on those, to me is just it's just such a nostalgic sound.
Oh, for sure. It's great, when you don't have to maintenance those, but I know that sound, and it'll knock you right out. It's a great sleep.
Yeah. It is. Well, Derek, how would you feel about walking out onto an admittedly already swaying bridge in a thunderstorm?
I'm gonna go ahead. That's a no for me, dog. I'm good.
Yep. Well, that's exactly what an entire battalion of French troops did in Angers while crossing the Angers Bridge in 1850, on April 16th, 1850.
France. I can't wait to insult the French listeners we don't have yet.
There's so much to do there. There's so much ammunition.
They're clearly not in their army, you know what I mean? Hey.
Well, they have too much ammunition because they never use any of it.
Oh. No, it's great. I love bridges. So we got a battalion of folks. Do you know how much a battalion is, just for my frame of reference? Is that 40s?
So it's several hundred. So a French battalion, let's see. I should have looked this up.
Oh, we got time.
This is one of those really niche,
right? Were they even
military historical?
One of our listeners, just off the top of their head, is losing their minds right now. How do you not know what a French battalion is?
It's just I don't.
No idea.
I don't know.
No, a couple hundreds is good frame of reference. Worst case.
Why is this so hard to find?
Dude, maybe even the French don't know.
That's probably a fair point. Because you have to realize, every time, they see, a squirrel or something, half of them are going to run away.
Oh, yeah. I found a glass of wine, so let's finish that real quick. Have a nap.
Oh, we found the baguette. Time to stop marching. We're going to get taken out by Big Podcast again if we...
You're going to get taken out by Big French at this point. Sorry, France.
They couldn't. They couldn't. Okay, so a Napoleonic battalion consisted of 1,000 men.
Whoa!
Now that's a little bit before. It's a little bit before what we're talking about.
That's a good frame of reference. Even half of that's a lot of folks on one bridge.
Yeah, so let's just yeah, so I'm finding another one that's saying between 800 and 900 men.
Oh, yeah, that's a lot of folks.
600 is, so I think it depends on like what specific time frame, and I'm just not bothered to, I'm not going to be bothered to look that up
Yeah, I
so
wouldn't worry
carefully.
about it.
But let's just say it's about 600 to 800 men.
All right.
That seems to be a good consensus. So let me kind of set the stage for you, and tell you a little bit about this bridge. So the Angers Bridge, also called the Bassé-Chain Bridge, I don't know, that's
pretty
French
good.
pronunciation, I don't know, was a suspension bridge that was over the main river in Angers, France. It was designed and built between 1836, 1839, and of course the collapse happens on April 16th, 1850. All the bridges we've talked about so far have been iron chain link bridges. This is actually a cable bridge.
Oh, we're installing cable?
We're installing
Oh,
cables.
yeah.
So basically, it is a 102 meters, which in freedom units is 335 feet.
Thank you.
Bridge. And why are we even doing meters? We don't like meters. And it's a 24-foot wide bridge, and the towers are cast iron columns, basically, and they are about 18 feet tall.
That's a heavy column.
Yeah, and so those are like the main piers that are going to be holding up the bridge. So basically what happens is that there's a military base nearby that they use to train soldiers and all this stuff. And so they've been coming back from an exercise, and a couple battalions have already passed back over the bridge and gone back to their barracks. This third battalion arrives in the middle of a thunderstorm. And so the thunderstorm is obviously, it's raining very hard. There's a lot of wind, and they get to the bridge, and the bridge is oscillating because of the thunderstorm. And this is basically like an aerodynamic effect that's happening on the bridge. So we've talked a little bit in the past that suspension bridges are inherently less massive than like a traditional arched bridge. Part of that means that part of the structure of a suspension bridge means that you have a fairly like narrow, like the actual solid section of the bridge is fairly narrow. And then the suspension cables are really what's providing the structural integrity to the bridge. However, Derek, have you ever like stuck your hand out the window?
Oh, yeah.
When
you car surf as a kid?
Exactly, right? And so like, you know how like you hold your hand flat, and any little change in angle of your hand can really like move your arm up and down quite a lot if you're going fast enough.
Good old-fashioned negative pressure you're getting down there.
Yeah, and so basically this same concept applies to suspension bridges. And so as the wind is blowing, that can create turbulence around the bridge and can cause the bridge to start flexing, both up and down, and then also side to side, depending on just how the wind is behaving. So the French soldiers get to the bridge. They see that it's swaying, obviously, quite a lot already. But they have their orders, and their orders are to go back across the bridge.
Yeah, RTB. So
wait a minute.
Did they break step?
So they break step, right? So they've been ordered to break step. We've learned a little bit, but they start marching across the bridge. And what ends up happening is, basically, Derek, have you ever been carrying like a sheet of plywood and it's windy?
Gosh, yeah, the thing's going all over the place.
And it's going all over the place. Well, in high enough wind, basically what you're doing when you have this many people marching across a bridge is you're just increasing the square footage that the wind has to act on.
Oh, I'm just making a bigger sail with all those men instead
of
just
making a bigger
parts?
sail.
Oh,
yeah,
I didn't
because
even
you think
consider
about
that because they're connected to the bridge.
They're connected to the bridge.
That transfer of force.
Yeah, exactly.
Crap.
So the wind acting on the soldiers causes the bridge to oscillate more. And then, so now, one of the eyewitnesses is basically like, they had been walking as if drunk and could barely keep themselves from falling, first to one side and then the other. So basically, the wind is pushing them, and then the bridge is oscillating, and then the soldiers are starting to stumble, and
Oh.
then they're trying to correct themselves. And so now, like, everybody's actually still matching the sway of the bridge because they're trying to stay on their feet.
Oh, so by them not falling over made it worse?
Yes.
Huh.
Right? So, because if you imagine, right, like the bridge is already swaying. So now you're trying to keep your balance. So you're not trying to really march in step at this point, but
Mhm.
you're all reacting to the same motion of the bridge.
Oh, okay, so the same input is making it's like you're marching in step because you're all like, oh, leaning to the right to like counteract the force.
Exactly.
Crap.
So they are trying to stay upright, and they're trying to maintain their balance, and this is causing the bridge, and they're acting as a big sail, and this is really just causing the bridge to continue to oscillate more. And then eventually, at a time, the bridge was covered with 483 soldiers and 4 other people. Although it's noted here that the police had prevented other people from joining in the march. I don't know what it is about the 1800s and people wanting to join in the march, but people really want to do it.
They just decided, like, I guess there's, like I said before, there ain't nothing else to do. Like, oh, the battalion is going by. I'm French. Let's go march.
That's true. The French people really do like marching to just wherever.
Just go ahead
they
and
can.
march, you know? Hey, they got some bridges, so that's something, right? Like, these are fairly new concepts, all things considered. The suspension bridge.
So basically, what happens? There's 480, I guess, 7 people on the bridge, and the upstream anchoring cable breaks, and there's this sound like a badly done volley from a firing squad. Quote.
Ooh.
And it snaps, and it breaks its concrete mooring, and shortly thereafter, the adjacent anchoring cable snaps, and the bridge falls into the river.
Oh, man, that's a lot of folks. How do we know how high
Yes.
this bridge is compared to the last?
I've got this picture that I'm looking at, and it looks pretty high. I mean, I would say it's probably every bit of 30 feet.
Oh yeah, you can break some with that.
Yeah, let me go ahead and send this over to you so you've got it. So yeah, so you can see in the foreground there's like some boats, and this is a bridge that's tall enough to allow boats and small barges and stuff to go under it.
Oh, that's cool. It's a really pretty bridge when it's together.
It's a beautiful bridge. Yeah, it really is quite beautiful. And you can see they've got basically these big concrete platforms on either side of the banks of the river, and then those big cast iron towers that are supporting the suspension cables. And then if you look on kind of the far end of the bridge, you can see there's this there's this concrete block that the suspension cable is anchored into.
Gotcha.
And we'll talk about that a little bit more in a second. So basically, many of the people who fall, I think they're falling probably about 30 feet is what it looks like to me, just kind of by eyeballing the image. And they're falling into water, so they're not hitting the ground, which is better.
Yeah.
And falling from 30 feet up into water is not a fun experience, but it's not like you're going to break stuff.
If you
you're not
discount the bridge coming down on top of you.
That's a fair point, right? There's obviously more than what's going in, but basically they get thrown into the river, and a lot of people are rescued. A lot of the fellow soldiers, right? This is a battalion, right? So there's about 800 people who are on hand and ready to help, basically, which is good.
That's convenient.
But still, like 226 people end up getting killed in this tragedy.
Yeah, that's a lot of deaths. Like, that's more than half of what was on the bridge.
Yeah.
And you got to think, like, humans become their own deadly things when there's many of them together falling and hitting each other. Like, your noggin,
right?
You meaning
and
your head.
Again, you got to realize, like, these are not just random people in civilian clothes. They're soldiers with bayonets and guns and gear. Yeah, I mean, so if you look at the the soldier of the time, like, they could have easily been carrying 60 to 100 pounds of gear.
Ugh.
And if you've ever tried swimming with 60 to 100 pounds of gear, it is not easy. at all.
Mm,
In fact, it's generally not really possible. You're going to have to drop a lot of that stuff.
man.
And the river near Angers, the main river, it's pretty big. I mean, so it's a deep river, and if you're out in the middle of it, and again, a lot of people at the time did not really know how to swim very well. So
I can't make assumptions about the French army, but that's something you learn in the services, right? Like even back then, wouldn't they teach you how to cross a river and swim and
not
like, wade water?
necessarily. So, like for example, in the British, I don't know about the French, but like in the British Navy, you'd imagine like they would teach their sailors like how to swim.
I mean,
right? You'd
in
think
the
so.
Navy, yeah, I'd hope so.
Well, Derek, let me ask you a question, right? If you're on a boat, and you wanted to not be on the boat anymore, how would you get off the boat?
You just go ahead and dock that bad boy, maybe a ramp.
Well, let's say that your superiors don't want you to get off the boat.
Oh, just jump. Just yeet it off. Wait,
All right,
you're not
so
supposed to get off the boat.
But yeah, you're not supposed to get off the boat, right? So like this is a situation, right? Like you don't want to be on the boat anymore. You're like, maybe you've been pressed into military service.
Oh.
And you've got an opportunity to get off the boat by jumping into the water and swimming away.
Oh, you're just going to walk the plank yourself?
Right, like you could just jump off and swim to shore, right?
I don't know. How far away? I mean, I guess if you're close enough to land, but they don't know how to swim?
But yeah, but if you don't know, if you don't teach your sailors how to swim,
yeah, you can't desert.
You can't desert if you can't swim.
I'm sorry, that's actually a really great idea. It's like, hey, we don't teach you how to swim. You can't swim away. That's really dark.
It is. It's really bad.
It's really dark. But it makes a lot of sense.
But it makes a lot of sense.
Holy cow.
And so. Yeah, exactly. And of course, this is before the time of like recreational swimming.
So your boat sinks, you just like, you're not trying to recover anybody?
Yeah, so well. Like, unless there's a lifeboat pretty damn close or something to hold on to float.
Instant doom.
You're pretty much done. And then the other thing too is like, if you're actually out at sea,
right, it
doesn't matter if you know how to swim or
you could swim 100 miles, you're probably not touching nothing. You're going to exhaust yourself, get eaten.
So, yeah, so from the naval standpoint at the time, like, it just didn't make much sense.
We will not teach them how to swim. Genius.
Perfect.
You can't desert if you can't leave. That's perfect.
Exactly.
Holy cow.
So, I don't know if that's the equivalent, or if the French did the same, or if they were more invested in their people being able to flee. But I would imagine that the Navy, if the Navy is not going to teach you how to swim, the Army sure as heck ain't going to teach you how to swim.
Huh. Oh boy, how times have changed.
I know, right? So basically a lot of people get killed. And there's a couple different factors to this. Derek, what do you think maybe caused a bridge to fail?
Well, you're talking about all that isolation, so bridges are meant and designed to have some level of cyclic loading. You're expecting, a boat might hit it. Oh, the wind's going to be variable. But do they do the math this is one of those very weird situations, right? You have a battalion of men fighting the wind, becoming way more like aerodynamic drag than what would ever be considered normally, right? That's the equivalent of what? Putting sheets up on the side of it and making a sail. I'm gonna guess the cyclic loading caused that concrete barrier that we saw to just fail before the cable actually would? Maybe? Sort
of. So, yeah, you're on the right track. So, Derek, we've talked a little bit about, well, we haven't really talked a lot about the anchoring structure of this bridge. So let me tell you a little bit about how I think that from what I can gather, I think that this bridge, the anchoring structures were made.
All right, let's go.
So basically what you have is the cable that's carrying the deck is anchored into this concrete, and where it breaks between 3 and 4 meters into the concrete underground, right? So basically the cable is actually it's what I think that they probably did was they have this cable strung, and then they've got it looped around probably like a bar or a block, and then they basically cast that whole structure into concrete so that it can't pull forward through the concrete,
Oh,
right?
that
So
makes
that's
sense.
anchored into the ground, right?
Yeah, there's no if it's cast correctly, you wouldn't even have to worry about it. It's just a bundle inside of the thing. That's pretty smart.
Yeah, so that's the idea. Derek, what do you know about reinforced concrete?
I'll be honest, little. I know little. I know it's like a mix of like concrete isn't what we think it is, like as civilians, right? Like isn't concrete like the bonding agent or something? If it's like sand
It's
and other
well, that would
things?
be called like
Or am I thinking
that
of
would be
cement?
basically like yeah, that'd be cement, right? So cement is generally referred to as like it's like kind of the fine powder that is like the binding agent, I suppose.
So cement make
And then
concrete?
so sort of. So cement is a component of concrete.
Oh.
So concrete generally refers to like the cement and the aggregate, which is like the gravel,
Yeah.
basically. And then in the case of reinforced concrete, what you're actually doing is you are putting steel, usually rebar, into the concrete in a kind of a grid in order to help the concrete withstand tensile loading, right?
Okay, so that
So
like gives it something to
concrete,
bind to, like more surface area contact kind of situation.
yeah, kind of. So basically, the idea is that if you've got the if you've got the steel inside the concrete, when you have tensile loading, the steel is actually able to handle that tensile load, and the concrete doesn't have to nearly as much. Does that
Okay,
make
so it
sense?
makes it where it's less likely to crack because there's something else to take that brunt.
Correct, right? So concrete is really, really good at handling compressive load. So if you stack a whole lot of weight on concrete, it's going
Perfect.
to take it like a champ. But if you start pulling on concrete, it's going to fail very, very rapidly and very, very unexpectedly because concrete is at its core a brittle material,
Hmm.
right? Does that make sense?
Makes sense. To answer your question, apparently I know nothing about concrete.
Fair enough. Well, let's talk a little bit about concrete. So, concrete is, as I said, a relatively brittle material, and it does not have a very high tensile strength. Steel, on the other hand, has a very good tensile strength. It's very, very strong in tension. And that is why that reinforced concrete is used so often because it combines the very diverse strengths of the two materials, right? So concrete is relatively cheap. It's very easy to manufacture, and it's
Hmm.
very easy to like use for kind of um, like volume. I guess like the volume to fill out the volume of a structure. Concrete is excellent,
Okay.
and then of course it has an immense compressive strength. Steel is extraordinarily strong in tension. So by combining the two, you really get a wonderful material that is very strong and it's relatively inexpensive and it's very easy to manufacture because you can basically just set up the steel lattice work and then pour the concrete into it.
Oh
And then what
yeah,
you
save yourself a
have
lot.
is you save yourself a lot of trouble in the manufacturing.
That sounds really
So
smart. Like they,
yeah, it's really, really great.
the more you know.
But there
Oh,
are some things that can be problematic with reinforced concrete structures. What do you think might be a problem with reinforced concrete?
well, it doesn't matter how strong the inside is. Concrete is at least partially porous. If we're talking about weathering, like if liquid gets down inside of a crack and just continues to get down, because this is a bridge, right? It's right next to a river. It's fair to
It is.
say that there's going to be some erosion at the base, of course, and probably, wind shear, like you're talking about of how it failed. It is strong enough to cut through the Grand Canyon over many years. I mean, I'm guessing the same effect, except
That's
less time.
true. Although I would say like that's actually more of an issue potentially with like just bridge pilings in general,
Gotcha, it's not
right? So
concrete specific.
yeah, so we will definitely talk about erosive failure of bridges, but that's not really what we're dealing with in this case.
What we got?
So, what's one of the really big problems with steel when it's exposed to the elements?
Rust, right?
Yes.
Like iron
So
oxide?
what do you know about rust and steel?
Well, I know that nothing eats away at steel faster than a good bit of rust. Like, you've seen it with, like, old tools and stuff. You can actually, like, chip it away with a fingernail, and to think that was steel, it really destroys the lattice structure and puts a lot of, I guess, what is the right word? I guess particulate within it. So,
Yeah, I guess so. So one of the things that rust actually does, um, when it is forms, it actually expands, right? So if you have, and in reinforced concrete, this can actually be a really big problem because remember that concrete is actually really not very strong in tension. So if you basically, one of the ways that you can break concrete, right, is if you drill a hole into it
mhm.
and then you just pound a wedge in there. What you're doing is you're creating a tensile load on the concrete because you're trying to drive it apart.
Huh. So if you press,
And
like,
so
press
you'll
concrete together, big strong,
big
rip
strong.
concrete apart, not strong.
Exactly. So you can it's what's called spalling, right? So
Spalling.
let me give you a picture as well. Spalling concrete. So basically what can happen is if the steel starts to rust within the concrete, what'll happen is the steel expanding, right? So the steel rusts, and as it rusts, it expands, and it'll actually break apart the concrete.
Oh, so that's why, like, I've seen this on, like, the side of highways and stuff down here.
Yeah,
That's what
yeah,
causes that?
that's what causes that. And so usually what happens because having so one of the interesting things about steel reinforced concrete is that steel is actually like mildly basic, and that actually tends to counteract the growth of rust.
Huh.
Right? So by having the steel encased in concrete, you're actually protecting the steel from rusting.
So you're telling me the only tin that concrete is, or reinforced concrete is, on the pH scale is a tin because it's basic as hell?
It's basic as hell. It is a little bit basic. Yeah,
Huh,
absolutely.
that's good to know. I guess I've
Um,
never worked with, I work in labs, Jim. We try to avoid rust at all costs.
that's fair.
We just
That's
don't make
fair.
it out of stuff that can rust.
That's true. Yeah, like and a lot of that's true because in chemistry, like you're working with like a lot of salts and things like this, right?
Hmm.
And so yeah, having like a stainless steel, like everything in a lab is going to be made of
Right.
stainless steel,
That or
basically,
some
right?
specific type of metal. Like, their smaller, more expensive things might be made of titanium depending on what it's used for. But you're right. Yeah, like, we'd
Right.
never use untreated steel for that reason. Last thing you want is a bunch of microscopic rust particles in whatever you're trying to do.
Yeah, it's just going to contaminate everything,
Destroy
right?
your analysis. Terrible.
So yeah, but so what can often cause concrete spalling is obviously if you have exposed steel, that's going to create an avenue for rust ingress and water ingress. But also, concrete naturally cracks a little bit when it dries because basically, you mix water into the concrete.
Hmm.
And so when the concrete starts to dry out, it shrinks a little bit, and that can cause cracking. And that's normal
That's like
part
by
of
design, just
that's
part of it.
well, it's just a normal part of concrete. Um, and that's one of the reasons that concrete is not very strong in tension is because you kind of have these natural cracks that form.
So it starts having cyclic loading as a part of its curing process.
It's kind of a one-time thing. So
Okay, it
basically,
doesn't like change every time it gets hot.
yeah, well, so it does have some thermal expansion, but that's not really a cyclic load because the whole structure kind of moves as one unit.
Oh, okay.
And actually, one of the really convenient things about concrete and steel is that steel and concrete have a very, very similar coefficient of thermal expansion. So basically, they expand and contract with temperature at a very similar rate.
Perfect.
So it's perfect. Yeah. So in a lot of ways, like reinforced concrete is a perfect material. However, as you may have noted, I didn't really talk about the concrete piling being a steel reinforced concrete structure.
Oh, you never. Yeah, you just kind of went to. Oh, this is how great this is. The French didn't use it.
Well, not in this instance, right? So this is actually a little bit before the widespread adoption of steel reinforced concrete.
Oh, they
And
had to learn the hard way.
Sort of. So, Derek, what's one of the really big differences between steel reinforced concrete and having a tension cable embedded in concrete?
Oh, you just told me concrete's not good under tension. So you're putting something under tension inside the thing that's not good at tension?
Well, there's that,
It's like moving,
but
isn't it?
also,
The cable.
yes, the cable's moving, right? So what happens when you load that cable and unload it, right? Because we're talking about the cyclic loading.
Yeah, you're just gonna like open a gap between where this. It's supposed to be a perfect seal, but like over time,
Yes.
you're just gonna like start grinding the own concrete away with the. Oh,
Yes,
that light bulb goes off.
Derek. So
See the
what ends
problem.
up happening is there's two factors at play. There is this factor of, okay, as you pull on the steel cable
Mhm.
and it vibrates a little bit, it's going to kind of wear out the concrete around it. That is a factor. But another factor to this, Derek, is the modulus of elasticity of concrete, which is to say basically how ductile it is.
Mhm.
Is
Those stretchy,
between it's between 30 and 50 gigapascals. Concrete is actually really hard to determine the modulus of elasticity because it really depends on the aggregate size and like are there, how much solids there is versus how much air pocket there is in the concrete and this kind of stuff. So it's actually not a very easy thing to calculate, but it's generally agreed that it's between 30 and 50 gigapascals. The modulus of elasticity of steel is typically about 200 gigapascals.
Oh, yeah, that's metric.
And what this really means, it is a metric measurement, but the point of it is that steel deforms much, much more than concrete under loading. That's what that really means. So if you pull on that steel cable, effectively what you're going to have happen is that steel cable is going to expand ever so slightly inside that concrete. And because so like one of the ideas of, we have to talk about Poisson's ratio a little bit. I didn't realize we were going to have to talk about Poisson's ratio.
Now we learn.
So basically, Derek, the idea, what do you know about like matter and energy? What can't matter and energy do?
Well, I know the laws of conservation of it. Can't make more of it. You can only transfer it.
Exactly. So basically, the idea is that you cannot make more matter, or you can't without basically taking an enormous amount of energy. Right. So volumetrically, this steel cable is a fixed volume. So if you stretch that steel cable in one direction, what's going to happen to the diameter of that?
It's got to get smaller.
It's got to get smaller. And that's exactly what Poisson's ratio is, right? So Poisson's ratio, or the Poisson effect, is basically the idea that if you squish something or if you stretch something, the volumetric, the volume of that material has to stay constant. Right. So Derek, if you stretch a cable that's embedded in concrete per se, what might happen?
I don't know. Like, it's getting thinner, but it's got to go somewhere. Is this just causing it to expand inside the very...
Well, so basically it gets thinner, right? And so that's going to break that seal between the concrete and the steel.
Oh, so you're allowing like things like water to get through.
And now you're allowing water to ingress into the concrete.
Oh, so it's less about the interaction of the steel to the concrete. It's the fact that you're making space that wasn't there before.
Exactly.
Oh, and we didn't think about seals back then. We hadn't gotten that far.
We did not think about seals. Yeah, and so like this is why in modern suspension bridges, you don't really see the cable, the suspension cable itself directly anchored into concrete.
Right, it's usually connected to something else.
It's connected to something else that then transmits that, and then a lot of times it is loaded into concrete ultimately, but it transmits that load usually as a shear load into concrete. And that's a much, there's much less chance for that to create gaps, which will then allow water ingress. So what happens is basically the cyclic tension load on this cable separates it from the concrete, which allows water to penetrate down into the concrete where it can no longer dry out, right?
Oh, that's
And
great.
and it can't be painted because it's inside a concrete block. And you can't see the rust forming because it's inside a big concrete block.
Oh.
And so what has happened over time with the Angers Bridge is that water has seeped into the concrete and the cable interface. And it's corroded the cable 3 to 4 meters underground. And so when it finally snaps, it snaps at that rust spot, basically.
And you
And
wouldn't be
it
able
fails
to detect
very
it.
suddenly.
You wouldn't even be, if you were inspecting the bridge
And they wouldn't have even
perfectly.
known.
Yeah. Oh man. I would know that was kind of roundabout to get there, but there's so many factors and variables to deal with. And this is just a bridge. Like, that's the crazy part. This is just one bridge in 1850.
Yep.
And water. Like, that's, little water got in it. Shame.
A little water got in it, and that's what happened. So basically, they finally come to the conclusion that the failure was based basically from the dynamic load due to the storm and the soldiers,
Okay.
but primarily the corrosion of the cables.
So it wasn't
was
the
found
soldiers'
to
fault
be-
at all, obviously, because they were just bystanders, pedestrians.
Yeah, the soldiers. I mean, they don't know anything.
Yeah.
Right. Like they don't know anything about
that's
the
not
bridge construction.
For them to know. This isn't the Corps of
Exactly.
Engineers. Yeah. So they didn't
Exactly.
do anything. Like what I'm saying, like, before the soldiers, we didn't know to break step. They broke step. They did the best they could. This was going to happen anyway. After
Eventually, the corrosion of these cables, and they found that the anchorages, the cable anchorages at the bridge were highly vulnerable because the cement was believed that was supposed to rust proof them. Like the designers believed that was going to prevent them from corroding.
Right.
But in fact, it made it worse because you could not see the corrosion happening.
Oh.
And you could do nothing to stop it.
So the risk mitigation measure was their very downfall because of lack of
was.
inspection. That's wild.
Because they've created a thing that basically couldn't be inspected.
You just got to go with it.
And yeah.
It's not one of those things that fails a little. I know that sounds really stupid, but like in biology, we have like warning signs. You have side effects and things. You can, for example, easy example, poison ivy. You can feel the itch before you necessarily see the rash sometimes, right?
Right.
It just kind of happens. You got full rash instantly. And it's, how many years had it been compromised? Like, that's crazy to think about.
Yeah. And because it's rust, it's a growing problem. And because you have, like, every time it rains, basically, water is going to seep into the crack between the cable and the concrete and continue to expose the steel to moisture, which will cause it to rust.
Damn.
And because it's happening so far underground, in the concrete, basically, there's really not much that you can do to see it.
The only way you could ever know is if the rust happened to travel up the cable at some point. But by that point, it's too late.
Exactly. And I mean, and you're going to have some rusting on the cables in general, just because it's
exposed. Like there is a threshold of normalcy there.
Correct.
Man,
Correct.
so this is just something every engineer had to learn the hard way with this one.
Yeah, this was something that they had to learn the hard way. And basically what happens as a result is that France doesn't build any more suspension bridges.
Oh, they just said no.
They're like, we're done with this. We're not going to do any more until 1870. They don't build any more suspension bridges until 1870.
No, mad respect for being like, let's sort it out before we just... Because doesn't that sound American as hell? Ah, damn, our suspension bridge broke. But it lasted 20 years. Build another.
Build another one.
Build the same one.
And this actually, in the engineering world at the time, like raises a lot of serious questions about suspension bridges, because this is coming up, like this is just 5 years after the bridge in Yarmouth collapses.
Oh, so like now there's a steady trend, like the same generation can remember and now be afraid.
Exactly. So so basically people are really starting to question suspension bridges as a viable structure. And they start using various different methods, and they're learning from this, right? So like the Brooklyn Bridge, famously, is a suspension bridge. And one of the things that they use that really comes about because of this is they basically have a reinforced deck to help deal with some of these wind loads.
Oh, that's cool.
Right, because one of the contributing factors to the failure of the bridge was the storm load. Basically, the aerodynamic loading caused by the high winds is a big factor in the suspension bridge failure. And so a lot of bridges going forward are going to employ some sort of structure or aerodynamic like fairings or baffles or whatever
so you
to
can
stop
direct the
this
wind on
loading.
purpose.
Exactly. And so
That's
that's going to become, we'll talk more about that later. There's another bridge that we'll talk about that is a huge factor.
Man,
So,
this bridge is
um,
it's kind of sad. It's a beautiful piece of engineering. Like, I know we just have the drawing because it's very early times, but it's
It
a
is.
gorgeous looking bridge. And to think visually, there was nothing wrong with it. It's just one of those things you never see until it fails.
It is.
And it makes me wonder, how many of those things do we still have today that we just don't know yet?
And so that becomes like a really big
Oh, and that's
thing.
it gone?
And so I've just sent Derek a picture of the bridge gone, and you can see like on the side that failed, basically like those beautiful cast iron support columns have been pulled into the river and crashed down into the waterway. Yeah.
That's an incredible. So this is a painting, right? Like someone sat on the edge of the land and painted, or is this an actual photograph?
I think this is like a newspaper illustration.
Oh, so someone just drew this? That's awesome.
I think so. This is a little bit before like pictures, I think, would be used very widely.
You don't gotta know French to know the word catastrophe.
I like how I really do think it's very funny that French and English are actually very closely related languages.
Yeah, the Latin
and some
basis.
of the French words that I guess have influenced English words. But so from our perspective, the French words that look like English words are just spelled funny.
Right. I guess, yeah, we're just like, technically we're talking, we owe it to the French and Latin basis that it has, but, not going to give them that.
Exactly. Yeah. It's just like catastrophe, DuPont, suspendu. It's just funny. Yeah, so just from our perspective, I think it's very funny.
I love that. I'm guessing it's just the guy who drew it is probably named Angers, but it's like they angered the bridge.
Well, that's the name of the town, right?
So that's how you spell that?
Yeah, so it's literally spelled anger, S.
And how do you pronounce it properly?
Angers.
Oh, okay.
I think. I don't know. Someone who's French and listening and hasn't clicked off the podcast by this point.
If they're sticking in at this point, they can never say the French surrender again because we've given them hell for an hour.
Absolutely.
Man.
But yeah, so that's the story of the failure of the Angers suspension bridge. And again, it causes a pretty big ripple effect. There's no more suspension bridges built in France until 1870. So nearly 20 years. And also, there's a report that's done in 1853 on the problem with the cable anchorages. And a lot of other bridges in France are very carefully inspected and scrutinized to prevent similar failures. So that is the story of the bridge. Derek, you have any thoughts on it?
I mean, this is just a classic example. If you refuse or choose not to learn from history, you're doomed to repeat it. And this is a great example. Absolutely. I appreciate the fact that, at least from what we have public knowledge, right? The French government was just like, hold up, there's something we don't know. Let's, send it to the engineers, let them go to conferences, let them learn from other countries. And the fact that they waited, some people would see that as a weakness, but it's really not. It's really admirable. They're like, let's get it right and choose if we even want to build this anymore.
Yeah.
Because you could see a lot of other countries at this time in history where like there's so much competition between countries as the communication is getting more and more frequent and possible with like telegraph and all of that. There's more global competition. There's more of a global economy instead of just your countries. The patience to wait 20 years to get it right, admirable. That's good.
For sure. Well, Derek, I think that's all for this episode of Everything's a Spring. Do you have anything to plug?
No, man. Everyone have a great holiday if you celebrate, like whatever you celebrate. And if you don't celebrate any religious holiday, just spend some time with your friends and family and find a reason to.
Absolutely. That's very wholesome. But also shout us out on our Twitters and Instagrams and all this stuff that we do. And let us know how your Thanksgiving was, and let us know if you got any awesome holiday plans.
Mm-hmm.
And if you've got any spectacular ideas of holiday disasters that we might cover, let us know down in the comments. Maybe we can do like a Christmas special.
Yeah,
That'd
that would be awesome. Yeah,
maybe
I would highly recommend folks, like, you know, I know that we have some international viewers now. They listen on Castbox. I couldn't tell you how to leave a comment on Castbox, but take an example from one of our friends from New Zealand. You know, I'm not asking you for the extra view. Go to YouTube, go to Spotify, whatever you have. Drop us a comment. If you don't want it public, we understand. The world's a scary place. Just shoot us a DM on one of our accounts. We'll see it.
Yeah, tell us how you found us, what you like about the show. And
if you want to cuss us out in French, oui.
Yeah, tell us how to pronounce angers. And
yeah,
some
I
of
guess
this,
some
like,
French
stuff.
like major is just upset right now, just infuriated.
I am constantly, you know, the thing is, Derek, as an American, if I've pissed off at least one Frenchman today, I've done my duty to God and my country.
Yeah, we've been doing that since 1776. Let's go.
Oh gosh. Well, Derek, let's bounce.
Let's bounce.